Please welcome to the stage Vice President of Security for AWS Sales, Marketing, and Global Services, Hart Rossman.
Hello, everybody. Thanks for having me here today. You know, as a security leader, I've long lived by the idea that you can't protect what you don't understand. And the cool thing about being in security is that there are lots of opportunities to learn new things. Curiosity has to become your superpower if you want to be successful over a long period of time in this space. It also doesn't hurt if you can rock a fly fit, if you know what I mean, right? And so a year and a half ago or so, generative AI took the world by storm. It's not a new technology space, right? Companies like Amazon have been working in machine learning and generative AI for quite some time. But the way in which the public was able to interact with it changed, and all of a sudden became compelling, became exciting, and a gravity well of innovation. It's a seminal moment in the security space, right? If we want to help our customers, if we want to help our communities, if we want to help our businesses innovate that same speed, that same passion, then we have to deeply understand the underlying principles of the technology, the applications that our customers are looking to use it for, and develop new ways of securing so that we can move quickly. And so as we're going along here, right, I think it's imperative as a security leader that you deploy that curiosity, right? You personally may not have identified a use case for your team or your organization, although we're going to help you with that a little bit in today's talk. But we also want to make sure that we're really asking the business, asking our customers, what's interesting about this new technology space? What's innovative? What's driving your passion to use it? So we can help you go faster and innovate bigger with the technology. And so at the beginning of any transformation in industry, this question comes up again and again. Can we move fast? Can we be secure? And do we have to make a trade-off? And I think once again, AWS and our customers have demonstrated that you can do both, that you can move fast and stay secure. It all starts with updating your mental model, how we think about securing the workload, securing the business, securing the innovation. AWS published the scoping matrix a number of months ago, and it's a distillation of some learnings we have that help you as a security leader, you as a builder, you as an auditor, think about the different use cases that you might deploy generative AI technology, and to start to use many mechanisms I'm sure you already have in place. Things like threat modeling, things like business requirements, documents, and analysis, right? Application security reviews, right? And make sure that you're connecting them all in a way that makes sense for a particular application of generative AI. And so we've been using the scoping matrix for quite some time within AWS for our own builders' use. And we've learned a couple of things as we build, deploy, and operate these workloads in the security community. One of the first things is that it's really important to get those fundamentals of identity and access control correct across the workload, right? Principle of least privilege, ensuring that nobody uses that generative AI service to gain access to information they wouldn't ordinarily have access to, right? Now with technologies like CEDR and verified permissions, using AWS IAM and Access Analyzer, right? And Control Tower, organizations, and other services, that's really easy to ensure, but it's something you need to think about end to end, right? The second thing that we've learned in the enterprise is that it's really important to collaborate with the data owner, the data custodian, right? One of the questions that often comes to me is, should I, as an individual contributor, develop this really cool idea I have around a Gen AI workload, right? And the first question I always ask them is, have you talked to the data owner? For all you know, maybe it's already on their roadmap, right? And you can really be more of a customer feedback provider rather than having to go to the trouble of developing the whole use case yourself. But it also allows you to have that conversation with the data custodian and sort of optimize not only the use case, but the security model, whether you build it or they build it, that gets deployed appropriately. And then the last big thing that we've learned is that when something is new, people often get focus locked on it as the shiny object. And you have to remember that particularly in the enterprise, a Gen AI workload is not deployed in isolation. It's part of an interconnected or distributed system. You might use retrieval augmented generation. You might be outputting to a data visualization system, right? And so you really want to take the whole architecture into account and ensuring that you're putting the proper controls in place, that you're auditing the full infrastructure and the full life cycle of the work stream. Things, again, that you would typically do, but sometimes in the rush to innovate, people, again, get that focus lock. And so getting that end-to-end privilege, principle of least privilege right, working with the data owner, and ensuring that you're really taking into account the entire architecture are recipes for repeatable, scalable success when you're adopting a new technology at scale like generative AI. Now, I'm excited today to have a number of customers and experts with me on stage, the first of which is Phil Vachon from Bloomberg. He's going to tell us about some really interesting things they're doing with generative AI technology. Phil?
Thanks, Hart. Good morning. Good morning, Philadelphia. Better turnout than I expected after a night of probably everyone hanging out with vendors. So glad to see that. So as Hart said, my name is Phil Vachon. I am the head of infrastructure in Bloomberg's CTO's office. And my team's role is to drive the platforms and the foundations on which Bloomberg builds its applications to deliver those amazing apps to our clients. One area that we've been focusing on very heavily in recent years is on public cloud adoption at the company. And there's three core patterns we have for adoption. First is looking at where we can run our own applications in the cloud, and we have certain applications that we do run in AWS. Those are, an anomaly for us because we are primarily a data center first company. However, there's another area that's really beneficial, which is enabling us to burst for additional capacity. And we'll talk about that a little bit in the context of large language models. And then finally, many of our customers, probably many of you in this audience, are actually on their own cloud journey, and they're migrating from their own on-premises infrastructure into AWS and other cloud providers. So we want to make sure that our products, services, and capabilities are as close to our customers as is possible. We want to make sure that as they're on their migration journey, we're there along the way. So at Bloomberg, we have a long heritage of innovating about how we deliver our services to our customers. In 1984, when we first introduced the Market Master, we did not have the concept of a global internet. We did not have PCs or workstations on everybody's desk. And in fact, hardware that would allow us to readily deliver a rich experience that allowed customers to discover those insights they wanted to do their jobs, that wasn't really cheaply available either. So what did we do? We built it. We built what became one of the world's largest frame relay networks and eventually one of the world's largest public IP networks. We built our own terminal, physical hardware, again, what Mike is leaning on right there, to deliver that service to our customers. And of course, we actually built our own concept of hypertext before hypertext was outside of the academic space. Again, this is before the World Wide Web and any of that. As industry has evolved, so too did our strategies and our adoptions of technology. So, for example, today, the terminal, the idealized version of which is in the background there, is a Windows application that runs on a normal PC. We have an awesome keyboard that people can get that's a remnant of our heritage of building our own hardware. And of course, the terminal itself is actually largely an HTML5 and JavaScript application that is built on the same underpinnings as Google Chrome. So as industry has evolved, we have evolved to keep up. When it comes to this whole AI and ML concept, we were early adopters as well. In 2009, we were releasing products allowing our customers to compare and gain insights, look at sentiment, all sorts of very useful measures that made it easier for customers to discover information about what they're trying to understand, the insights they're trying to glean in the markets. So to that end, over the last 15 years, we've built up a stable of over 300 AI and ML researchers out of a company of 23,000 employees, 9,000 of which are actually engineering staff. These engineers and researchers are doing everything from developing the techniques for how we apply machine learning and AI to public markets and public markets applications, as well as conducting fundamental research into how these applications can be built, and even in how these models develop or operate. So over the last 3 years, we have published over 100 papers in this subject, including the Bloomberg GPT paper, which I'll talk about in a moment. Of course, behind the scenes, there's a lot that goes on to support these folks in doing their job. You need people who are actually planning how we secure these things. You need to make sure you have people who are creating reproducible patterns. You have to make sure that all of that telemetry can be collected and used to ensure that that training workload is doing exactly what it's supposed to do. It's a team effort. And why are we so interested in machine learning AI, and why do large language models pose some very deep interest to Bloomberg? Well, let's look at some of the numbers of data that we're dealing with. We deal with over 300 billion market events per day. That's anytime there's a market where there's an asset being priced and a trade being made, we're there. We're collecting that data. We're archiving it. We're making it actionable. That's more data in a single data points in a single day than tweets that Twitter handles in a year. We have over 200 million trusted documents that we've curated over the years, some of which we've built in-house with our own analysts. Some of this is research that we've developed ourselves. Some of these are earnings transcripts, all extremely valuable for putting context around what you're trying to understand about your market. We also ingest over 1.5 million stories from 125,000 curated news sources. Can you imagine one person trying to sift through this and understand exactly what's going on? It's a lot of work. So when the GPT-3 paper became public, and even before that, we became very excited about what the potential was for large language models. So we embarked on training our own research model. This was, in the end, a 50 billion parameter model, much smaller than what GPT-3 was, but was built for us to actually research for non-commercial purposes how large language models could help our customers and how we'd go about building such models. This was actually trained on AWS. We used SageMaker to drive the whole process, and it was on top of 512 NVIDIA A100 GPUs over a 53-day training run. So a lot of GPU time. So as we went through the process of training models, and we've continued to iterate on this process, and as we move forward on putting the outputs of some other types of models in front of our customers, we have to look at what are some of the risks that you need to address as a part of this. First, those training data sets are extremely valuable to us. That's core to our business. We don't want to lose track of them because someone could abuse them. Second, your model weights. You just spent a lot of money training that model. You don't want to lose them, or worse, have someone abscond with them. And last, as Hart was alluding to, you want to make sure you use data that you are supposed to use when you're training these models. Don't misappropriate data you're not licensed to use, or worse, use data that relates to some aspect of your business that you should not be using for training models. You need to make sure that you don't have any loss of your resources. Those GPU reservations are extremely valuable. And of course, it's very tempting for someone to just jump in there and try to do another experiment or whatever on top of another training run that's going on. We have to make sure we shut that down. And the other thing too is we want to make sure that if we are doing an experiment, we have the right guardrails in place to shut it down so it doesn't run amok. So we don't end up in a position where we have an unexpected bill because of a model training run that was left running over the course of a weekend or long weekend. Of course, as a domain expertise concern, AI and ML researchers aren't infrastructure experts. We need to enable them to move quickly. We need to enable them to do their jobs securely and reliably. Finally, as you move into the realm of inference, you have to really be thinking about who is using the models and how they're using those models. We don't want to use the wrong model for the wrong purpose. We don't want to expose capabilities of that model or features or ways to use that model that aren't in line with our own policies. We want to be trustworthy for our customers in our use of AI and ML. And finally, make sure you standardize how you protect those API endpoints, because that is a key part of ensuring that your models are used appropriately. So what do you have to do? Well, the infrastructure as code approach is wonderful, because that means you are capturing all that knowledge that you have built up in each time you've done this, each time you've set up to train or whatever it may be. So as I mentioned, Bloomberg is a data center first company. We want to make sure that we have our direct connect plumbed in properly, that VPCs are properly set up with the right policy. We want to make sure the right secrets are deployed. So if you're accessing APIs or whatever it is, they're deployed in a way that's secure from our on-premises security secret stores. We need to make sure that the appropriate keys, customer-managed keys, are in place so that when we encrypt our data at rest in S3 buckets, we are ensuring that we are keeping control of that data. And of course, we want to make sure we instantiate SageMaker, Bedrock, whatever tools and technologies our users are going to ultimately be using. And access to S3 buckets is key, but when you're doing a training run, you need to keep those training nodes busy. So FSX is a great technology built on top of S3 buckets. You need to configure it correctly. And finally, of course, you need data. So you need to leverage AWS's capabilities to move data from on-premises over that direct connect into S3 buckets with the right policy attached. So one thing you want to be sure about as well is that no one's instantiating or using any AWS products that you should not be using. Nobody needs a ground station as a part of their training workflow, normally. Finally, let's talk about security controls. So security controls are best left to the domain experts. Getting IAM policies correct is a bit of an art and a bit of a science as well, and takes a lot of experience. If we had to turn every ML researcher and engineer into an expert in this domain, I think they would be stuck moving a lot more slowly than they would like, because this is an area that's moving very rapidly. So we try to codify that knowledge of our security architects and of our infrastructure engineering teams into a common building block that everyone can use. Of course, that means deploying the right IAM policies, deploying objects in an S3 bucket with the right access policies, and of course, your customer managed keys, make sure you're controlling those properly too. But these are all details that you want to make sure your ML researchers don't have to worry about. Next, I should say, we want to make sure this is easy to use. So a low friction mechanism for people to deploy new experiments. People should be able to tear down an environment and rebuild it from scratch, because a lot of experiments probably won't work out. And that's an important thing to consider. If you're not doing something interesting that's pushing the boundary, you're probably not going to see any failures. So if you're seeing failures, it means you're up to something interesting. But it also means you need to be able to iterate rapidly to recover from those failures. And then, of course, we want to make sure that we build the right building blocks on top of that environment we set up, so that if you need to deploy a particular technology, you need to access a particular resource, it's easy to do in a compliant way. And of course, on top of all that, make sure that all of your normal security controls are deployed. Telemetry, logging, monitoring, all of that. We need to make sure that that is front and center. And then, we're big users of Kserve for deploying models themselves on top of AWS and on top of our on-premises infrastructure. We want to make sure that whatever infrastructure we use is consistent and the environment is consistent. And finally, I can't emphasize this enough, make sure you capture your lessons learned, and everything you do is repeatable over and over and over again, and you don't keep learning the same lessons. So what are the key lessons to learn? First, we want to make sure that we enable experimentation. We want to make sure that ML researchers can move at the speed of research, and this is an area that's moving rapidly. Next, we need to enable rapid iteration. We need to be sure that we can allow those folks to tear down and rebuild an environment and be sure that that environment truly has been torn down. And finally, we need to be able to scale rapidly. So when that research bears fruit, when you see that the model deployment is actually going to be part of a production application, you're able to scale up the resources as you need. And most important of all, most AI and ML researchers and engineers are not infrastructure and security experts. And if you do find one who is, hang on to them. They're a gem. And make sure you allow them, though, to focus on what they do best. So keep the infrastructure as an enabler for all of them. So with that, I'm actually going to hand it over to Emily, who is going to go into some more detailed AWS offerings. So thank you very much, everyone.
Yeah, we're good. All right, good morning. Hi, my name's Emily Weber, Principal MLSA at Annapurna. I've been with Amazon for 6 years. Most of that time I've been working on SageMaker, helping customers like Bloomberg actually with large-scale distributed training. And last month I moved over to Annapurna, which is a startup that Amazon acquired a number of years ago for infrastructure development. So Annapurna built Nitro, that enables secure cloud operations and instances. We built Graviton, which is custom ARM-based processing. And we're also working on Trainium and Inferentia to give you the best price performance for accelerated machine learning on the cloud. So let's dive in. So first, I'd like to present a data science approach to securing foundation models. How's a data scientist going to think about this? First, I like to think about where the model is coming from. What are the origins of this foundation model? What does the training data look like? What does the source code look like if I can analyze this? How was that model aligned with customer preferences? Can that model follow instructions? Can that model have an enjoyable conversation? Does that model understand the difference between fair and non-fair? Can that model operate in a low bias and a highly responsible manner? Nonetheless, these are a lot of questions. It takes time, it takes work, it takes effort to determine the answers to those questions. This is one of the reasons why it's really valuable to use a managed service from Amazon, because we've done a lot of this low-level work for you. We've validated many of the dimensions of the models, and so you can inherit some of those benefits by using managed capabilities, whether that's through Amazon Bedrock, so that you can simply invoke these models through an API, or through Amazon SageMaker, so you can use pre-built images with SageMaker Jumpstart, or get much lower in the model customization process. But that's only the second step, just validating that the model is meeting your needs. When you're landing the solution for an application, for a use case, for a team, there are many other aspects that I'd like you to consider. We're going to explore some of those today. And an interesting one to consider is education, educating auditors, educating inspectors, helping the rest of the teams understand the philosophy behind why a foundation model operates the way it does, understanding some of the key terms and technology so that they can better enable the onboarding of that. And so Amazon Bedrock offers excellent secure model customization. Right from the start, none of the data that you use to customize your foundation model, none of that is held, none of that is maintained, none of that is used to train your model. Whether that is essays that you put into your prompt, whether that is custom instructions, whether that is context that you send to the model for retrieval, or whether that is actually supervised or unsupervised pairs for fine-tuning. All of this can be encrypted in transit and at rest, You can establish Bedrock VPC endpoints, so you can ensure the network connectivity, and you can enable AWS Private Link to mitigate any of the data egress to the public internet. And so there are many ways that you can securely customize your foundation models. But again, even this is just the beginning. I'd like you to consider evaluating and protecting your customer actually from unwanted outputs. Once you've validated that a model meets a use case to a reasonable criteria, we need to think about mitigating negative outputs from that model, whether it's a hallucination, whether it's just wrong guidance, where maybe the model is still accurate, but it's just directing the customer in a way that's not optimal for them, or the content from the model could possibly, again, be biased or be toxic in some capacity. And so even after we've validated that the model achieves a given performance level in a use case, we need to actually establish robust model evaluation capabilities on top of that. So Amazon has an excellent stack for model evaluation. We have an open source library called FMEval that operates with complete transparency. You can point to a model hosted in Bedrock, in Jumpstart, or in a third-party model provider. You can bring your own data to that, select a number of algorithms, and then see how well that model is performing on use cases that you care the most about. Many of the metrics are also available in Bedrock and in SageMaker. So SageMaker will provide the more data science focused metrics. Bedrock will provide the more application developer metrics. This also includes human-in-the-loop capabilities when a given mathematical algorithm isn't quite cutting it in terms of that human touch. And so you can enable human-in-the-loop model evaluation for this. And so you can establish and develop automatic evaluation pipelines that help you ensure that over time, as the data change, as your customer preferences change, you can run the same repeatable evaluation criteria using the model evaluation stack. So I definitely hope that you'll explore this today. Once we've developed and trained our foundation model, then we need to establish guardrails and protection criteria for the model on inference. So let's look at some of the ways to do this. Guardrails in Bedrock are an excellent start. You can establish a number of topics. Within the topics, you can even define how intensely you'd like that guardrail to be enacted, so low, medium, and high. You can go in great detail about the description of this topic, what it looks like. And then this will look at content that's coming in from your customer and also look at content that's coming in from the model and not allow a communication to be shared that doesn't fit your criteria. And so guardrails are a great way to get started. If you'd like to create some of your own discriminative text classification models to provide a little bit more context-based classification, you can do that on SageMaker with LlamaGuard, which is a pre-built model that is a classifier. And you can also fine-tune models like this on contexts and on language and in use cases that you care the most about. So these are some great ways to get started. Now let's look at how we put all of these services together. And so at the lowest layer in integrating generative AI with security, you need observability with CloudTrail and with CloudWatch. You need to be able to configure content with config. You need networking capabilities with VPC. You need private access with private link. You need to lock your objects with S3 object lock so no one's inadvertently deleting a model artifact. You need AWS backup, and then you need AWS Nitro to ensure that the network operator doesn't have access to the content that's running on your instances. And then at a level above that, there are a number of purpose-built security tools that you can use across the board, whether that's with Amazon Macie, Inspector, Detector, IAM, Security Data Lake, Web Application Firewall. We have many, many options that you can and should be taking advantage of. And then all of these will work nicely with the generative AI tooling at the top of the stack, whether that's with Q, Q for builders, Q for developers, or it's Bedrock or SageMaker or anything else you would like to use. So I really hope you're learning about and taking advantage of these tools that are built for you, so you don't have to build them. You can simply use what we've built on your behalf. But there was something missing. So I'm excited to share with you today the security reference architecture for Bedrock. So this is a new launch that came out earlier this week. That link will take you to the documentation page where you can read all about it. And so the security reference architecture for Bedrock shows you how to put all the tools together, not just for a development purpose, but actually in the context that Hart mentioned earlier, the context of a database, the context of an application, the context of a number of security tools that you can use to provide assurance and privacy. This hinges on the concept of an OU, or an organizational unit, which is a logical grouping of AWS accounts designated for a given purpose. And so we suggest an organizational unit for generative AI. This helps you mitigate the impact of a generative AI incident, and it helps you ensure that the controls and the access of the generative AI capabilities are scoped appropriately. Also lets you do updates to that separately. And so definitely encourage you take a look at this. And here's an example. I hope most of you are exploring something similar to this today. So the Amazon Security Data Lake, of course, is a great way to capture all of the security data that you need and put it in a single place. Now, the Security Data Lake requires SQL queries to use, and like many data sources, it takes some time to understand the different fields, understand how they mean, and then actually act on them in an incident response scenario. What you can do is you can take the metadata about the Security Data Lake or any other data lake you're interested in, you can give that to Bedrock. You can give that to Claude in the context of a prompt and give Claude examples within that prompt of how to generate SQL queries. And then Claude, through Bedrock, can generate many SQL queries for you for Amazon Security Data Lake. It can help you interpret those SQL queries, debug them, look at the responses, and take action on them. And so this is a fun project to work with. And now I'd like to take a look at the lowest layer of the stack, which is securing the AI infrastructure itself. So fundamentally, we believe in three principles here in our journey towards zero access to sensitive AI data. First, we believe in the complete isolation of your AI data from the infrastructure provider, which is AWS. We also believe in your ability to isolate AI data from yourselves, from your own admins, from your own developers. This is especially important for confidential computing and for highly restricted data such as personal health information, personal financial information, and any other content that you absolutely do not want to share, even with your own internal developers. This is also true for an LLM weights, such as for inferencing. And so we've established that, and we've delivered on that through Nitro Enclaves with KMS. And then now we're extending that to Nitro Enclaves with KMS, extended to ML accelerated hardware. You heard a little bit about that in the keynote earlier this week from Chris. We're going to dive into that right now. And this enables protected infrastructure communication, which enables end-to-end encryption for generative AI. So let's take a look at this. There are two dimensions here I'd like to share with you. That dimension one is ensuring protection from the infrastructure operator and your sensitive AI data. And that first dimension is enabled through Nitro. The Nitro system that underpins all modern EC2 instances, that ensures that no one from AWS has access to your data, to your content that is running on your EC2 instances. And so that enables the first dimension through Nitro. And then to enable that second dimension, which is mitigating the ability for your own admins and your own developers to access your own content, that's enabled through Nitro Enclave. And so the Nitro Enclave is accessible through a single parent EC2 instance and one dedicated socket from that parent to that EC2 instance. And then we've built it connected through KMS. So when you want to send content to execute on the Nitro Enclave, first it's encrypted by KMS at the beginning, passes through the socket, and then it's only encrypted if it meets the criteria that you define. And so this is how we enable highly secure and confidential computing, such as for LLM inferencing. And so Nitro Enclaves with KMS, again, will be supporting ML-accelerated instances, starting with Trainium 2 and the upcoming instances. All right. And then I have one more launch for you, so I'm excited to share publicly for the first time. This is the Neuron Kernel Interface, also called NIKI. NIKI is a way for machine learning developers, engineers, and data scientists to define your own models for Trainium and Inferentia. So again, at Annapurna within AWS, we're developing purpose-built accelerators that are designed for machine learning, training, and inferencing that give you the best price performance on the cloud. This can be anywhere from 20 to 40, sometimes 70% better price performance relative to comparable EC2 instances. You're going to learn a little bit about those benefits in our next talk coming up here in a second. And so NIKI is a way to write your own kernel for Trainium and Inferentia. Using Python, using PyTorch, and familiar frameworks for machine learning, data scientists can now define their own models, their own operators, and execute that directly on our hardware stack. NIKI executes as the entry point for the compiler, actually. So when you're writing code and writing kernels in NIKI, it gives you a way to define mathematically, using our library, the mechanisms of your model, and then accelerate that model quickly. And this enables self-service model innovation and rapid onboarding, and it's built, again, on the Nitro system to ensure security by default. And so with that, I'd like to invite Jacob on stage to learn more about it.
Morning, everybody. I'm Jacob Solowitz, co-founder and CTO of Arcy. We're a year-old Series A startup building AI infra on AWS for everyone who's training LLMs so they can be rebuilding essentially their own Bloomberg GPTs. So we founded Arcy with the idea that everyone was going to be rebuilding their own small language models for specialized capacities. And the fundamental routines that we formulated for this involve training and merging small language models, and then owning that and deploying it in your environment, which is, of course, where a lot of the AWS tools come involved in the platform and the infrastructure that we built. Why SLMs? So this is something that I think everybody is kind of realizing in organizations is that secure inference is a really important thing in terms of not providing customer data across API calls to different services, which is not good for your customers, also not a secure way to be sending data across the wire. But even more than that, it means that you're not owning your own proprietary IP. And you're not if you're sending an API call, you're not owning proprietary IP in the form of model weights. So if you don't have your own model weights and you haven't trained your own model, then you're not actually building core IP to your business. And for startups, that's something that they're not able to own, and their competitors are able to essentially launch the exact same products as them. And for large corporations, the same thing is true as well, in that the competitors will be having the exact same inference that they have, which means that there is no edge behind the AI that you're building. The other thing that's better about small language models is, of course, because they're smaller, they're much more scalable. This means that the training costs and the inference costs are a lot slower. So also for a quick benchmark, the range that I'm talking about in terms of small language models is about 7 to 70 billion parameters. So this is what you could look at most LLM solutions today, what people are building on top of general intelligence APIs. Most people are building what is sort of a fragmented system where you have essentially like a retrieval index, retrieval augmented generation, where you're retrieving relevant documents to ground your model in the domain that you're building in. And you're also maybe doing fine tuning, where you're taking the model and you're steering it by giving it alignment of input and outputs with the way that you want to train your model. And both of these suffer from kind of two fundamental flaws that we see at RC. The first one is in the retrieval context, the actual core generator itself is not aware of the domain data that you're sending into your model, which means that you're not necessarily getting the deep semantic understanding of the ways in which language is used within an organization or for the product that is being delivered. And then in terms of fine-tuning, the problem that people are having is catastrophic forgetting. So you start with a general model that's very intelligent, and then you train from there, and you essentially have destroyed the weights of your model along the process. And there's a lot of things that you need to do very carefully to recover back to that state. That means that you need a team of 300 AI engineers like Phil has at Bloomberg in order to get back there. So here's kind of the solution that we're building. It's all revolves around model merging, which is a new technique that we have released open source. MergeKit is an open source LGPL repository that you can use and you can pick up. Essentially what it does is you take the parameters of two language models and you merge them and you keep the capabilities of both models. This comes out of research theory, essentially, that language models have extra space in their parameters where you can actually hold the information of the two models in the same parameter set, and that turns out to be true. There's a lot of different methods that you can do to do model merging, but the popular ones are well formulated within the MergeKit. And there you can see kind of the star history of adoption that we've seen of people using MergeKit to merge their models. And then the most practical usage of this is actually to merge back into the general chat checkpoint. So now you have a general model that's very strong that's getting released, like Llama 3 or the Qwen series models that you've seen now. And then you do your training, and then you merge your model back into the general chat checkpoint. And this is proving extremely efficient in many, many different scenarios. So this is kind of like a little bit of a paradigm for LLM model training that you could usually think about. So this was true ever since the Transformer was released in the BERT paper, where there's stages of pre-training and fine-tuning. Pre-training where you're creating knowledge through next token prediction, and then fine-tuning where you're steering the model to actually respond in a useful way. And so the fine-tuning was really released with ChatGPT, where they found that they could actually have this model chatting in a way that was useful and kind of seemed like a human was responding back and forth. And rather than just kind of writing poems and things like that, it was actually providing really useful responses. And so in that paradigm, people will sometimes, when adapting to domain knowledge, what you do is you do a continuous pre-training. So this is where you start from the general chat checkpoint, the general model that's been trained over the entire web, and then you start doing continuous pre-training to learn the tokens of your adapted text. And so this is something we're seeing working in a number of accounts and enterprises where people are actually getting domain adapted knowledge with anywhere from 100 million to about 1 billion tokens, which many organizations have. And then this is kind of a way to bake in deeper knowledge into your generator. And then that goes into your domain adapted pre-trained model, and then you merge it back into the general chat checkpoint. But here you can see then, right, you can still link this up to a RAG index in RC, and you can also still do alignment and merging as well back into the general chat checkpoint. But this is kind of the whole paradigm that's put together as AI infrastructure within the RC platform. And now we'll take a little bit about how this is built on AWS. So this is our a kind of a high-level view of our AWS infrastructure. So we deploy all in AWS VPC Cloud, which is, of course, very important for organizations that need to keep their model weights secure and private, and their inference secure as well. And AWS has obviously built all of this and built the starter pack for anyone who wants to build something like this. So this is how we did it with inside the VPC. We have a normal, platform and REST API on top of what is essentially AI infrastructure on top of MLOps routines that are running on EC2 and ECS. We're utilizing Trainium instances, Inferentia chips, and as well as NVIDIA GPUs in this infrastructure. And there you can see the various training APIs that are running on different machine learning instances, and then you can see the Inferentia chips running in the inference setting. So like I said, this is another list of that view, which is essentially all the AWS services that were built on top of. Another one that's really useful to think about as you're building these applications, if you are going to end up doing retrieval, is to look at Amazon OpenSearch Serverless, which is now publicly available, which is essentially serverless, like competitor to Pinecone. And you can see also the other services that we're using. This, like I said, is kind of the AWS starter pack to keep a platform secure and be able to manage users and keep data flowing where it should be flowing. Now, the next thing I want to talk about is just a little bit of advice for finding deep learning hardware in AWS, as not all of us are as fortunate as Phil to have 264 A100 GPUs at our disposal. There's two different routes that you can look at. So, of course, NVIDIA GPUs are very scarce right now, so there's two really good routes to look at. One is AWS Trainium, which is essentially a much better option and comparable option to NVIDIA GPUs, which I'll talk a little bit more in terms of benchmarks. And then there's also the AWS EC2 capacity blocks for ML, which is a new solution to reserve NVIDIA GPUs in block demands out in advance. We use both of these at RC. So here's a little bit of a look at a Trainium benchmark that we ran. So this was when we were developing our continuous pre-training infrastructure. We trained a 7 billion parameter model on Trainium instances on a corpora size of about 2 billion tokens. And this is pretty representative of the work that we're doing inside of our customer accounts. The Trainium hardware was a TR1N instance, and this was compared against kind of like a comparable EC2 generation of a GPU instance. And here you can see, like, in terms of the training time, it was much, much faster. And when you actually price that back out onto the on-demand costs, in a much more efficient training for us. So that's always something to look at if you're running scarce on GPUs. And then another thing here that we have is the capacity blocks feature. This is inside the RC platform, where if you want to launch on top of GPU capacity, you can pass that through the RC platform right into the capacity block. And so this is a good way if you need GPUs to plan out in advance, reserve it, and then you have the GPUs when you need them. So that's all I've got. I'm going to pass it back to Hart here.
Thank you, Jacob.
Yep.
Awesome. Right? And so there's so much innovation going on in this space. I love the use cases that both Bloomberg and RC presented, right? These are just two of many, many examples that when you're working on a secure foundation and you're applying best practice, you can do just amazing things in the enterprise. You can create new startups that fundamentally change the experience for customers everywhere, right? But why should we let the business have all the fun, right? So I mentioned earlier, if you want to be able to protect something, you have to deeply understand that. And the best way to do that with a fast-moving technology like generative AI and machine learning is to build things that help you do your job better, right? And so Emily shared with us a number of ways to set up a secure environment, whether it's inheriting security features from Nitro, right, to deploying with a security reference architecture for Bedrock. Where the excitement happens, where the rubber meets the road, though, is in security operations. And security operations personnel, right, they deserve to have undifferentiated heavy lifting removed from their work as well, don't they? And so one of the workloads that we developed in Amazon and is running in production today is a Bedrock-based support system for incident responders, right? It helps them reduce ambiguity and makes available to them the institutional knowledge we have about resolving security issues across Amazon, right? And that's really important when you want to move fast, when you want to stay secure, when you want to identify, triage, and resolve issues as quickly as possible, right? You want systems that make that responder efficient and fast and focused, right? And so we've built just such a system. One of the things that we had a question about, a hypothesis, is how would a responder use it? How much benefit would it provide? And is it something that they would really integrate into their workflow, right? The ability to ask ad hoc questions about an emerging security issue, right? And get generative answers, and then correlate that with other tools and investigative techniques we have, right? And so we were really excited to see that responders love it. In fact, on average, any new security issue that comes in, they'll use 10 prompts to start the investigation and triage of that issue, right? Which is really fantastic. And of course, the more prompts that they use, it moves from being ad hoc to being queried, right? Prepared queries. So you can templatize those over a period of time, and then essentially pre-fetch useful information for that responder that then frees them up to ask even more contextually appropriate ad hoc queries as we go. And so what does that do? It speeds up triage, right? It enables better data-driven decision making. It provides insights to common root causes and trends, and also history of resolution techniques, right? Get the best solution fastest into the hands of that on-call or the responder. And it empowers security engineers to self-serve, right? Emily gave us a use case that she suggested you all try yourselves, and I absolutely endorse it, which is not only building a system like this, but thinking about the automated response that you can build on top of it, right? You can absolutely not only templatize the prompts, the queries, but then you can also automate the actions for certain repeatable, reliable outcomes. And so it's absolutely an opportunity as a security practitioner, as a security leader, to quickly and effectively adopt these technologies to reduce undifferentiated heavy lifting, to move fast, to be even more secure. And that gives you an authentic perspective. When the business comes to you and says, hey, I'd really like to build something like Bloomberg did, or I'd really like to build something with small language models like RC did, what's the best way to do it? And instead of just saying, oh, I read about this wonderful best practice online, you can say, as a security leader, this is how we deployed Bedrock in our organization to improve security operations, and here's how I recommend you take those lessons and apply it to your business use case. There's nothing better than that, right? One of the other aspects of investigation is, of course, response. And I've had the privilege for a number of years now to look after the AWS Customer Security Incident Response Team. The AWS CERT is the team that helps customers when they have an escalating issue on their side of the shared responsibility model. And as you might imagine, as we were getting ready to make available services like Bedrock, right, and Q, we were thinking about how will we provide the best response experience for our customers? How will we ensure that our incident responders in the CERT are fully up to speed on all the benefits and opportunities, but also all the areas of investigation required for a successful response, right? How do we go from a bump in the night to everything's all right as quickly as possible? And so we thought about that incident response lifecycle, and as you can see on the left there, the very first thing is preparation, right? And so we started talking to peer groups. We started talking to friends in industry, right? We said, how are you thinking about doing incident response when there's AI involved? It may not be the cause, but it may be impacted by a security issue. How are you thinking about doing response? And I'll be honest, we weren't loving the responses we were getting. People were saying, oh, we're just thinking about it, we're not sure. Many of these security teams actually hadn't deployed anything themselves internally, so they weren't quite sure how to get their arms around it. We say, gosh, you know, we've got to do something, and we've got to not just do something for our customers, we've got to do something that helps raise the bar for the community. And so we began to develop a series of hypotheses on the best possible way to respond to security issues where there might be a generative AI system co-resident, and also to start thinking about what are the best ways to use generative AI to improve investigative outcomes, right, for any type of incident response. And we came upon this mental model, which we're calling Mirai, which has 7 elements of investigation, some of which you're probably all familiar in the security incident response community, things like looking at access control, right? Looking at change over time, right? But now we're starting to look at AI changes, model changes, context changes, changes to weights, right? Looking at data storage changes, whether it's in a RAG type external system or whether it is in a system that you're putting output into, right? A lot of attention focused on invocation, right? How do we work with data scientists to look at the invocation method and over time, how that invocation has stayed the same or changed. And then of course, end-to-end privacy. And customers are increasingly using proxies as part of this. And so in some cases, the LLM is the proxy. You're asking the system that holds the model to take an automated action on your behalf. And in other cases, you have another system that's proxying the prompt or the invocation into the model. And so how do we think about that chain of trust and relationship? We've learned a lot from that. And so we're very excited this week to announce 3 incident response playbooks that we're open sourcing for everybody to benefit from to learn about how to best respond to Bedrock, to Q, and to some updates to our incident response playbooks and guides for SageMaker. And so this is the kind of best practice that we encourage all of you, our customers, take advantage of. But the Mirai mental model is something that really any response organization can start to apply to generative AI in any context, right? And we just want to do a little bit to help raise the bar for security for the entire community. So we're really excited about this. As I mentioned in the beginning, doing incident response is not something you want to try for the first time with a real escalating issue. So we encourage you to take a look at the playbooks. We encourage you to deploy some generative AI workloads and practice the investigative techniques. Why is that? Many of you are familiar with incident response on AWS, are probably just absolutely dialed in on using CloudTrail, for example. But if you've never looked at a model invocation log before, right, you won't be able to tell the whole story of what happened. You won't be able to triage in an effective manner. And the model invocation logs are awesome. They're actually relatively easy to read. They're very easy to parse and analyze. But if you've never worked with them before, right, the first time you do it shouldn't be during a live event, right? So get comfortable with telling that full story, and you're going to be on easy street. And so with that, I'd like to ask Emily to come back out here a little bit. I've really enjoyed getting to know Emily as we're putting this talk together. She claims she's a data scientist, but I think she's just hiding as a security engineer, right? And so I thought she and I would just take a minute to talk a little bit about the future of generative AI from our different perspectives, hers as a data scientist and mine as a security leader. Emily, you're going to come on out?
Thanks.
Again.
Likewise.
So as a data scientist, where do you see all of this going, and how can security help?
Sure. So I think the last few years have shown that, of course, generalized models that serve very intelligent responses on generalized data sets, obviously that's exciting. Just seeing the sheer increase in scale, it helps us ask interesting technical questions. But it's not particularly efficient. I think it's fair to say that intelligence is sort of an efficiency game in the sense that when you're looking at a particular use case, when you know how to solve that use case, it tends to be that a smaller, more purpose-built model solves that use case very, very well, as we heard from RC. And so I think we can expect trends to move in that direction, looking at more purpose-built, more highly efficient models that then we need to wrap our hands around and think about the entire application and how do we secure that.
Cool, makes sense. And my observations is that generative AI is another example of distributed systems, but initially thought of as a single monolithic application. And I think as you look at the stack that you described earlier, right, you've got that in there. And Nikki in particular really reinforces for me the idea that I really think generative AI is going the way of operating systems. Today, they're purpose-built applications, But I think in the future, the natural way to interact is going to be more like a command line interface, something like Nikki, right, a kernel interface. And that we're going to look at these specialized subsystems around storage, around networking, around physics modeling, a variety of things that give us that sort of collective operating system experience, but in a distributed manner.
I like it.
Super cool. Awesome. Well, thank you very much. Thanks, everybody, for listening today. And we hope you enjoyed Reinforce.
Thank you.
Cheers.